In part C of example 1.17, we have another equation that is f of x. And let's take note of the operations that we have here. We have subtraction, which we know subtraction doesn't have any problems with domain. There is also a squaring operator here, and the squaring operator also does not have any problems, but we do have division. And we are dividing by x squared minus x. So we are going to have to be very careful about what happens here with this division. So we are going to take just the algebraic approach here. We're going to take x squared minus x, and we're going to set it equal to 0, and we're going to look for what solutions there are to this equation. Now this is known as a polynomial equation. To solve a polynomial equation, factoring is the typical go-to technique. Now it doesn't mean factoring always works, but when it does, it is the most efficient technique. In this situation, there is a greatest common factor of x. So I'd have x times x minus 1. And there's a property for solving that says if I have two factors multiplied together that are equal to 0, then I can set each one of those factors equal to 0 individually. This is called the zero product property. I'll write that down. Zero product property. And there's probably a half dozen variations of that name. So you may have heard it called the zero factor property, or the zero factor law, or the zero product law. I've heard all kinds of versions of this. But ultimately what we do is the following. We'll take the first factor, set it equal to 0, and then we take the second factor and set it equal to 0. Now the first factor, set equal to 0, already tells me x equals 0. That's already solved. The second equation here, if I add 1 to both sides, I will get that x equals 1. These two values, if you think back to what happened in part A of this example, these are going to represent domain restrictions. So going back to that number line to help illustrate what the domain should look like, there's going to be a restriction at 0 and a restriction at 1. We represent a restriction using an open boundary, and then I want all of the other real numbers to be a part of the domain. So that means every real number that's less than 0, every real number that's greater than 1, and we can't forget all the real numbers that are in between 0 and 1. So this domain will be represented using three intervals unioned together: negative infinity to 0, union 0 to 1, union 1 to infinity. And that gives us our domain. And if you want to pause the video at this point and do some checking just to verify that it works the way that it's supposed to, now would be a great time to do so. I'm going to go on and take a look at writing the function definition. The name of this function is f. The domain I will just rewrite. And every element from the domain has to map to a real number. And the way that we will create the map is by using the equation f of x equals 1 over x squared minus x. So let me say that again. There is always going to be two parts to defining a function. There is the domain, and there is the equation or the rule that describes how to be able to make the correspondence.